Hi, welcome to my channel. In this video, we want to solve the following problem. In a circle, ABCD is an inscribed rectangle with BC equals 4 units and AB equals 2 units. MN is a tangent to the circle at C. Line BE is drawn such that it is parallel to MN and intersects AD at F. Our goal is to find the length of EF. And now for the solution. First, connect A to C and label the intersection of AC and BE as P, and then consider triangle ACD, the line MN, and the circle. Angle CDA is a right angle. Since an angle in a semicircle is a right angle, AC is the diameter of the circle. Let O be the center of the circle. Next, recall that if AB is tangent to a circle of center O, then angle OAB is a right angle. Since MN is tangent at C, angle OCM equals 90 degrees. Following this, consider the lines BE, AC, MN, and the circle. Since BE is parallel to MN, angle BPO is also a right angle. Since the perpendicular from the center bisects a chord, we have BP equals EP. BE, which equals BP plus EP, thus equals 2BP. Next, consider the lines BE, BC, and MN. Since BE is parallel to MN, angles EBC and MCB are alternate interior angles. Since alternate interior angles are equal, we have angle EBC equals angle MCB. Next, consider triangle ABC, the line MN, and the circle. By the tangent chord theorem or alternate segment theorem, we have angle CAB equals angle MCB. Following this, consider triangle ABP and triangle BCP. Let us show that these triangles are similar. Since angle PAB equals angle PBC and angle BPA equals angle CPB equals 90 degrees, by the AA similarity theorem, the two triangles are similar. Since corresponding sides in similar triangles are proportional, we have AP over BP equals AB over BC, or AP over BP equals 2 over 4. Therefore, AP equals half BP. Next, consider triangle ABP. By Pythagoras theorem, we have AP square plus BP square equals AB square. Since AP equals half BP, we have 1 over 4 BP square plus BP square equals 2 square. And so, 5 over 4 BP square equals 4, or BP square equals 16 over 5. Taking the square root, we have BP equals 4 over square root 5. Therefore, AP equals 2 over square root 5. Since BE equals 2BP, we have BE equals 8 over square root 5. Next, consider triangle APF and the line EF. By Pythagoras theorem, we have AF square equals AP square plus FP square. Using FP equals EP minus EF, which equals BP minus EF, we thus have AF square equals AP square plus BP minus EF whole square. Substituting AP equals 2 over square root 5 and BP equals 4 over square root 5, we obtain AF square equals 4 over 5 plus 4 over square root 5 minus EF whole square. Or after taking the square root, AF equals square root of 4 over 5 plus 4 over square root 5 minus EF whole square. Finally, consider the chords AD, BE, and the circle. Let's apply the intersecting chords theorem. Given two intersecting chords, the theorem tells us that A times B equals C times D. Applying the intersecting chords theorem, we obtain EF times BF equals AF times DF, or EF times BE minus EF equals AF times AD minus AF. Substituting in the known lengths BE, AD, and AF, we obtain this lengthy expression. After expanding the brackets and expanding this term, we obtain 8 over square root 5 EF minus EF squared equals 4 times square root of 4 over 5 plus 4 over square root 5 minus EF whole square minus 4 over 5 minus 16 over 5 plus 8 over square root 5 EF minus EF squared. 8 over square root 5 EF minus EF squared cancels out, and after rearranging, we obtain square root of 4 over 5 plus 4 over square root 5 minus EF whole square equals 1. After squaring both sides, moving 4 over 5 to the right hand side, and then taking the square root, we obtain 4 over square root 5 minus EF equals plus minus 1 over square root 5. Therefore, EF equals 3 over square root 5 or 5 over square root 5. To determine the value of EF, we turn back to the diagram. Since EF is less than EP, which equals BP, which in turn equals 4 over square root 5, we have EF equals 3 over square root 5, which is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.